The concept of classes is the foundation of object-oriented programming. A class can either have public components or private components. You can access public components, such as methods and events, from outside a class. However, you cannot access private components, for example data types and attributes, from outside a class. The figure shows a vehicle as an example of a class.
Characteristics of a class in object-oriented programming are as follows. A class is a set of objects that have the same structure and exhibit the same behavior. A class provides a blueprint for all objects based on this class. A class is made up of components such as attributes, methods, events, constants, types, and implemented interfaces, defined in the definition part. You can implement only methods in the implementation part. A class statement cannot be nested, that is, you cannot define a class within a class. However, you can define local auxiliary classes for global classes.
Attributes contain the data that can be stored in the objects of a class. The types of class attributes are as follows: elementary, structured, table type. Attributes can consist of data types such as local or global or reference types.
In class data statements, you can only use the type addition to refer to data types. The like addition is only allowed for local data objects or SY fields, for example, SY date, SYU name, and so on. The read-only addition indicates that a public attribute declared with data can be read from outside. However, the attribute can only be changed by methods in the same class. Currently, you can use the read-only addition in the public visibility section or public section of a class declaration or in an interface definition. With type reference to, you can type an attribute as a reference. The constant statement is used within the class definition to define data objects that have a constant value. If you use the type statement in the class definition, you are declaring a local type which is specific to this local class. You can create a local type to be used by one or more attributes within the same class. Private attributes cannot be addressed directly from outside the class and are not visible to outside users. You can protect attributes from outside access by characterizing them as private attributes. Note, the friendship concept is an exception to this rule. Public attributes are attributes that are visible to all users and can be directly accessed by outside users. Similarly, the constants and types defined by a class can be either private for use inside the class or public, which is accessible from outside the class. The public components of a class are collectively known as the class interface. Using the private visibility section is known as information hiding or encapsulation. Encapsulation protects a class user by making changes to private components invisible to the external user. You can change the private components of a class without changing the interface. Assume that the private components of a class are changed at some point, with its interface remaining the same. External users can still continue to work with the class as before. The external users can only access the components through the interface of the class and will not notice the internal implementation changes in the private sections. However, when the public components of a class change, every external user must take those changes into account. Therefore, use public attributes sparingly. or avoid making incompatible changes to public components altogether. Private attributes are defined in the private section of a class. Public attributes are defined in the public section of a class. It is syntactically impossible to access private attributes directly from outside. However, you can access private attributes using public methods that return or change the values of the private attributes. The slightly higher runtime requirement, that is, method calls in comparison with direct value assignment, is taken into account to satisfy the encapsulation concept. The signature of a public method clearly establishes which values must or can be transferred and which types are to be assigned to these values. The signature of a public method forces the external user to use the correct types. This method also ensures that all private attributes are dealt consistently. For the example in the figure, if the make and model attributes are public, it will be quite risky because the user may forget to supply the attributes or specify inconsistent attributes. To implement this situation, you can use a public method, setType, to ensure that proper values are specified for both the attributes. A strict syntax check governs method calls, ensuring the transfer of all required parameters. A method can perform a consistency check to see if a certain vehicle make produces the chosen model and raise an exception if an error occurs. To minimize runtime, individual attributes can be defined in the public visibility section, but you should then give them the read-only edition.
Different kinds of attributes are as follows. Instance attributes. Instance attributes exist once per object, that is, once per runtime instance of the class. You define instance attributes with the syntax element data. Static attributes. Static attributes exist once for each class and are visible for all runtime instances in that class. You define static attributes with the syntax element class data. Static attributes usually contain the following information that applies to all instances. Types and constants. Central application data buffers. Administrative information such as the instance counter. Technical literature refers to static attributes as class attributes. That is, we use the class data syntax element. As in C++ and Java, ABAP objects uses the official term static attribute. The figure shows how the NO vehicle's static attribute is related to other program elements in the memory. The static attribute exists only once in the loaded class, regardless of the number of instances of LCL vehicle. Therefore, you can say that instances share static attributes. Caution: an integer data object is defined to count instances. It is not possible to determine the number of created instances from the system.
Some of the key characteristics of methods are as follows. Methods are internal procedures in classes that determine the behavior of the objects. They can access all attributes in their class and can therefore change the state of attributes. Methods have a signature, such as interface parameters and exceptions, that enables them to receive values when they are called and pass values back to the calling program. Methods can have any number of importing, exporting, and changing parameters. All parameters can be passed by value or reference.
One return value can be defined in the method using the return parameter. When using a returning parameter, you cannot use exporting and changing simultaneously.
You assign methods to a visibility section to determine whether methods are called from outside the class or from within the class. Private methods allow internal modularization. You assign methods to a visibility section to determine whether methods are called from outside the class or from within the class. Private methods allow internal modularization.
You define private methods in the private section and public methods in the public section of a class. It is not possible to directly access private methods from outside. However, a private method can be called by a public method. In the example shown in the figure, init_type is a private method that is called by the set_type public method. Defining this private auxiliary method is useful because the instruction to initialize attributes may be used in other methods. Note, this is an introductory example. Later, you will learn more programming techniques for evaluating formal parameters. In a class, declarations of attribute names, method names, event names, constant names, type names, and alias names share the same namespace. Additionally, there is a local namespace within methods. Local declarations within a method override declarations made in the class.
Different kinds of methods are as follows. Instance methods. You define instance methods using the method syntax keyword. Static methods. You define static methods using the class method syntax keyword. You define static methods at class level. However, you can only access static components in the implementation section. This means that static methods do not need instances and can be directly accessed through the class. In the example shown in the figure, you can only access the n_o_vehicles static attribute within the get_n_o_vehicles static method. All other attributes are instance attributes and can only appear within instance methods. Technical literature refers to static methods as class methods compared to the class methods syntax element. In ABAP objects, the official term is static method, as it is in C++ and Java.
A unified modeling language or UML class diagram lists the class name, class attributes, and methods. The components in a class are shown in a UML using the following notations. Plus sign. A plus sign indicates public components that are visible to all users. Minus sign. A minus sign indicates private components that are invisible to outside users. Underline. An underlined component name sign indicates static components. Alternatively, the keywords public and private can be used as a prefix for methods. AUML also allows manufacturers of modeling tools to create their own symbols for increased visibility. The use of visibility characteristics is optional and is normally used only in models that are nearing implementation.
A class contains the generic description of an object and describes the characteristics that all objects in that class have in common. During the program runtime, you use the class to create discrete objects or instances in the memory. This process is called instantiation. When the class is accessed for the first time, it is loaded into the memory. Hint, although you can use classes and static components to write complete applications, the reason for using object-oriented programming is to create and work with the runtime instances of classes. To define a reference variable, use the data go_vehicle1 type ref2 LCL_vehicle, which is typed as a pointer to objects of type LCL_vehicle. The null reference is the initial value of a reference variable.
The createObject statement creates an object in the memory. The object attribute values are initial or assigned according to the value specification. Object reference variables can be assigned to each other. The figure illustrates an example in which, after the move statement, go_vehicle1 and go_vehicle2 point to the same object.
Independent references are references that have not been defined within a class. The garbage collector is a system routine that starts automatically whenever the runtime system does not have more important tasks to carry out. In this example, the reference to object toLCL_object is initialized. Thereafter, there is no reference point to this object. Therefore, the garbage collector deletes the object without reference. So since there is no reference point to object for LCL_object, it is also deleted. You can use the logical query if go_obj is initial to determine whether r_obj contains the null reference or it does not point to any object.
If you want to keep several objects from the same class in your program, you can define an internal table contains one column with the object references for this class. You can administer these objects in the internal table with the usual statements for internal tables, such as append, read, or loop.
The objects in the class LCL_wheel have their own identity. You can create objects regardless of the existence of an object in the class LCL_vehicle. References are transferred to objects in class LCL_vehicle to create the desired association.
You can use classes to write complete applications by using only static components. However, the reasoning behind object-oriented programming is to create and work with runtime instances of classes. A class contains the generic description of an object and describes all the characteristics that all objects of the class have in common. During program runtime, you use the class to create discrete objects or instances in the memory. This process is called instantiation. When the class is accessed for the first time, it is loaded into the memory. To create objects, use the statement createObject ref_name. You can only create and address them using reference variables. It is irrelevant as to which values may be written into which attributes. Technically, the object has an ID, in this case 5, which is not accessible. For example, create an instance of class LCL_vehicle, a vehicle object. The private attributes still contain the technical initial values.
Call method ref static method_name is the syntax used to call instance methods. When calling an instance method from within another instance method, you can omit the instance name, ref. The method is automatically executed for the current object. A shorter syntax is also supported as of in SAP Web AS 6.10. In this version, omit call method and list the parameters in parentheses. There must be no space before the parentheses, but there must be at least one space after the parentheses. When you call a method that has only one import parameter, you can specify the actual parameter in the parentheses without any other additions. When you call a method that only has import parameters, you can omit the exporting addition.
The receiving, importing, and changing parameters are mutually exclusive. Otherwise, the same rules apply here as they do for calling a function module. Use call method class name instance method _name to call static methods, also referred to as class methods. Like static attributes, static methods are addressed with their class name, since they do not need instances. As with instance methods, when you are calling a static method from within the class, you can omit the class name. Otherwise, the same rules apply here as for calling an instance method.
You describe methods that have a returning parameter as functional methods. This means that they can have neither an exporting nor a changing parameter. you have to pass the returning parameter using the value addition, that is, pass by value. You can call functional methods directly within the following expressions: logical expressions, if, else if, while, check, wait, arithmetic expressions and bit expressions, compute, case conditions, case, when, sources of values as a local copy, move, search clauses for internal tables, assuming that the operand is not a component of the table row, loop at, where.
In the first part of the example, two calls of functional instance methods represent the two addends of an addition. The second example shows the call of a functional static method in short form. The number data object is the actual parameter for the returning parameter of the method. The detailed syntax is as follows: data gv underscore number type I, call method lcl underscore vehicle instance get underscore n underscore o underscore vehicles receiving rv underscore count is equal to gv underscore number.
You access public attributes from outside the class in the same way as method calls. You can access static attributes using class name instance static underscore attribute. Access instance attributes with ref static instance underscore attribute. There are two types of methods in ABAP objects. They are not called explicitly with call method or the relevant short form. Rather, they are called implicitly. Constructors are the first type of method. The constructor is a special instance method in a class and is always named constructor. This abbreviated term actually means the instance constructor. The constructor is automatically called at runtime with the create object statement. When you define constructors, always consider the following points. Each class has not more than one instance constructor. Define the constructor in the public area. The signature of the customer can only have importing parameters and exceptions. When exceptions are raised in the constructor, instances are not created. So, no main memory space is occupied. Except for one exceptional case, you cannot call the constructor explicitly. Note, there is no destructor in ABAP objects. That is, there is no instance method that you can automatically call from the memory immediately before the object is deleted. The corresponding commands in the SAP library and the menu paths outside of the ABAP workbench are only contained in internal system calls.
After the instantiation of a class, a constructor is necessary for the following conditions. If you must allocate resources, if you must initialize attributes that cannot be covered by the value addition to the data statement, if you must modify static attributes, if you must send messages containing the information that a new object was created. The static constructor is a special static method in a class and is always named class_constructor. The static constructor of a class is executed only once per program. Call the static constructor automatically before the class is first accessed. You can access the static constructor before any of the following actions are executed for the first time. Creating an instance of the class using createObject. Accessing a static attribute of this class. Calling a static method of this class. Registering an event handler method for an event in this class. When you define static constructors, always consider the following points. Each class has not more than one static constructor. The static constructor must be defined in the public area. The constructor's signature cannot have importing parameters or exceptions. The static constructor cannot be called explicitly. You can address an object itself by using the predefined reference variable ME within its instance methods. You are not required to use ME as a prefix in such cases, but you can use it to improve readability. However, you must use the prefix ME static when distinguishing between local data objects and instance attributes with the same name. The case shows another important use. When you call a foreign method, a client object is required to export a reference to itself. Then you can use ME as an actual parameter with exporting or changing.